Hello everyone, thank you for having me. Today we're going to be speaking about one of the latest web standards and how it is enabling more secure, portable, and fast modern applications. Allow me to use an analogy. Typically, I like to use the universe analogy because I don't know if you folks noticed this, but our favorite programming language ecosystem is like the very universe we live in. We know it keeps expanding, it keeps accelerating, even at a time when many had predicted JavaScript would be outside of the picture already. Like the universe, our JavaScript ecosystem is still bursting with technology evolution, new frameworks, tools, patterns. But because this is Sailsconf, I will compare it with the depth of the sea. How much is yet unexplored and to be discovered? This rich ecosystem hosts the staggering amount of over 60 million developers, many of which contribute to the open source, developer tools, and standard ecosystem, making it richer, accelerating it, and making new progress and discoveries every time. They're the makers of JavaScript features in 1.8 billion of websites using JavaScript today. And we have for almost 3 decades been building user interfaces and experiences with JavaScript, but the current demands and needs of our end users have been developing over time too, and so have the networks and protocols that make data transmission possible. In a world where the access to information, media, entertainment in various interactive forms is right at the tip of our fingers, the attention span of an average internet user is of about 8 seconds. Now take a moment to reflect on that again. 8 seconds. It took me more than 2 minutes to get your attention, to get you to this slide. Our customers have only 8 seconds to get their audience's interest and reduce the bounce rate or the abandonment of an experience before any significant interaction. Before we set sails to explore the amazing innovation awaiting for us in the shores of JavaScript standards, let me quickly introduce myself. My name is Natalia Venditto, and I lead the efforts to improve and advance developer experience and tools for JavaScript developers building on Azure, as part of our customer-obsessed and data-driven developer division. I am also the author of microfrontend.dev, a website with free resources to learn and build composable front-end architectures and full-stack applications. Now, back to JavaScript. Being high-level in nature has had pros and cons for its developers and the application that we have been building, and notably, the following domains have presented the most challenges: security, cross-platform compatibility, and performance. And those are incredibly important domains because out of being lightweight and interpreted, JavaScript has had incredible levels of adoption, becoming the most used language in software development. JavaScript is everywhere now. It is, of course, in your online banking applications, the GPS, maps, apps that guide your driving, re-rendering the road as you go, in real time in your light bulbs, in your TVs, in your washing machine, in your cars, in space, in satellites and telescopes and spaceships and stations. That requires we focus more than ever on features like security. We need to secure the runtimes that serve compute for JavaScript to be everywhere and be part of everyone's lives in different domains. And because of that omnipresent in aspects of our day-to-day lives that go from entertainment and gaming to healthcare, navigation, banking and communication equipment, among other applications, from the web to a diversity of devices, cross-platform compatibility or portability must be a focal point. JavaScript is a powerful force multiplier for advanced features from browser to server, back and forth. And those new expanded horizons demand levels of speed and performance we can only achieve when running at lower levels. We can write and build full applications in JavaScript and run them as a binary with outstanding levels of performance in a diversity of environments. That's essentially what Wasm or WebAssembly is, and the superpowers it grants us as developers. Now, technically speaking, Wasm is a compilation target in binary format that allows developers to write code in their language of choice and has a toolchain ecosystem around it so we can compile it to binary and run it without the need for interpretation and leveraging low-level resources. JavaScript has an implementation of WebAssembly 1.0, a browser implementation, and it has also custom support with open source libraries. Wasm is incredibly powerful on its core features. For the W3C specification to be portable in browsers, it needed to offer a definition for imports and export bindings that the JavaScript community could agree upon and that would work with JavaScript engines across agents. This means that browsers can not only run that Wasm in its low-level binary form, JavaScript itself can import and run Wasm code as part of its execution loop. Now, WebAssembly does not specify any API or system calls, only a set of available imports defined by the host environment on the web or on the browser, and functionality is accessed through the web platform and outside of the browser with implementations like WASI. Languages have a WASI implementation or WebAssembly System Interface, a modular interface that provides POSIX-like features like file I/O and focuses on security and portability. Imagine a technology that leverages all the capabilities of JavaScript in the browser and can run on multiple operating systems. And on different chip architectures that have been developed over time and optimized over time. Support for JavaScript to WASI is now experimental, but these innovations are coming stable or becoming real stable soon. Let's notice also that these optimizations do not only result in more performant, accessible, and effective user experiences, but also in an enhanced developer experience from code to cloud or from developer workload to deployment or publishing, removing friction, decisions, and configuration steps, and simplifying troubleshooting and debugging when the development and the execution environment in production are containerized and consistent. The experimental WebAssembly execution engine for VS Code, for example, that uses VS Code extension host as the implementing API, enables the execution of Wasm process for any WASI compliant toolchain like the WASI SDK or the Rust Wasm-WASI target, Wasm32-WASI target, like the one used by Cloudflare's Wrangler, for example, compatible with Wasm time. And WASI is just one expression of this very, very rich developer ecosystem that supports Wasm as a portable language that can be executed in. Wasm runs on JavaScript engines like V8, the engine used in Chrome and now Edge, or the Chromium-based browsers engine. Wasm modules can be also executed standalone, import to JavaScript as we mentioned before, and they can also be componentized for compatibility. In the next demo, I will show you Wasm as a container for JavaScript, its most useful and ubiquitous partner across different execution contexts, like V8 isolates or workers for CDN-based functions, although other engines like SpiderMonkey, for example, offer the same functionality. It is no other than Wasm providing the container environment with its sandbox. For this demonstration of portability, I will be creating a Wasm, not module, but component from scratch, using the open source library I mentioned before, Componentize.js. The component model is a proposal to build composable Wasm modules. We will create a project and then create a Wasm interface describing a world and a JavaScript file that will be taken as input source by the SpiderMonkey embedding provided by the Componentize.js library to output a WebAssembly component binary with the same interface. Then I will initialize the project as a Rust project with cargo and import the necessary dependencies to generate the WASI output to run the component in Wasm time. We will also be transpiling the component using the JCO CLI developed by the Bytecode Alliance in order to run this code on Node.js. The custom WASI mapping provided by the transpile command allows us to direct the WASI component imports to the experimental JavaScript WASI shim. WASI support is already enabled for remote deployment and will soon see widespread adoption across the industry. It is available for workers, or what some know as JavaScript containers. The shims that make this innovation possible, although now in preview or experimental, are getting further developed and extended by teams of open source contributors and maintainers all over the world, and as collaborative efforts across providers. With this technology, we will be able to run the same Wasm code across a wide range of devices, regardless of if we wrote the original code in high-level language as JavaScript or low-level as C++. It is fully portable, interoperable, and runs on multiple POSIX compliant systems. We have demonstrated how we can run the same code in our terminal REPL as Node.js, as Wasm in the browser, and also deploy it to remote origin and edge functions. These collective advancements are the true spirit of open source and the technologies it brings to developers around the globe, and it's not unknown to JavaScript. All this innovation, new and faster communication standards and protocols like 5G, and rendering advancements and techniques like those enabled by the most modern JavaScript meta frameworks, enable composable architectures integrating features like server-side or hybrid server-side and static generation, and progressive bootstrapping of JavaScript, also known as partial hydration or island architecture, that enables sophisticated forms of composition and personalization, as well as the data fetching and presentation. Wasm and its evolution from modules to component push portability to new dimensions and enable levels of speed and independent parts of the application never accomplished before in high-performance web development. That in turn makes it possible to achieve extreme levels of decoupling and independent deployability and registration of modules, where teams can effectively choose their language and stack and compile to Wasm as target for an efficient, consolidated deployment, even at the edge of the network, to run compute, compose, and serve closer to the end user. And we're talking about highly complex architecture scenarios that flow from origin to CDN, not only for proxying and caching, but for computation, and that can recreate exactly the same execution contexts from origin to edge of the network, from development to production, while taking advantage of APIs and patterns that are available or can be bound or imported across environments. Not only will we will be able as JavaScript developers to take advantage of serverless models that are fully managed, declarative, and repeatable via tools like infrastructure as code and scale down to zero like never before, but also containerization with the provided levels of security, portability, and isolation beyond those provided by the classical tools used broadly across the industry, but that are less familiar and intuitive for JavaScript developers. Because of these new capabilities, we will be able to expand even more on the use of mechanisms available server-side, typically as services or as part of a module import, and then leverage event-driven architectures, data streaming, and data persistence across environments. Since the same patterns are also available client-side as part of a web standard or browser API or as a module import. Remember, we can package and deploy modules and components with all dependencies to run everywhere. And when I say everywhere, I mean in origin, at the edge of the network, tiny edge, devices, and client-side in the browser. Literally, for JavaScript developers, this means pushing the boundaries of isomorphism or even trisomorphism, or the ability to run JavaScript universally and at the highest unimaginable speed when executed as low-level code or binary like never before. I hope you have enjoyed this presentation. Please make sure to visit and share microfrontend.dev or aka.ms/contoso-real-estate-github for a real-life JavaScript architecture reference featuring composability, server-side rendering, event-driven patterns, and soon, Wasm. Thank you very much.